Well, I don't know. I was hoping to finish this farm boy by Christmas, but other things came along. I was encouraged to do some DIY and decorating, and I absolutely hate decorating. And then I started building a new PC. And then I've ended up sorting out my home network. But anyway, I think everything's sorted now. And in my last video for the farm boy, I started machining the governor. And in this video, hopefully, I'll finish it. So the first thing I'm going to machine are the governor weight fulcrums, of which there are two. Now the original drawing is fairly lacking in terms of information, to be honest. And I've done this to a scale of 2:1, so this is twice the size of the actual fulcrums. And the drawing shows the distance between these 2 points as 0.95 of an inch. It shows a radius on here of 0.125 of an inch. The width here is 0.25 of an inch. The width here is 0.2 of an inch. The distance between these two holes here is 1.616 of an inch. And the radius here is 35 degrees. And that's pretty much it. It mentions reaming these holes to be 0.094 of an inch. But it doesn't actually tell you the distance between sort of this point and that point, the centre of the hole. So I've done a bit of maths, and I've worked out that this distance from that point to this point here, I've called it x, is tan 35 is equal to x over 0.333, and that comes out at 0.233, that distance there. And to work out this distance here, I've worked it out on this basis here of this distance being half of the width, which is 0.125. So it's sine 55 equal 0.125 over y, so y is equal to 0.153. So I need two pieces that are of a width of 1.616 plus 0.125 twice, and the height needs to be, let me see, 0.233, this distance here, plus 0.153, which is this distance here, plus the radius, which is 0.125. So I work out that I need a couple of pieces of brass to be 1.866 of an inch by 0.511 of an inch. So the actual sort of width of this is going to be 1/8 of an inch, so I've got a couple of pieces of brass which is 1/8 of an inch thick. And what I'm going to do is, I've cut them roughly to size, but I'm going to super glue them together and then put them on the mill and machine them to the size I'm looking for. Once I've done that, I can then mark them up. Okay, so I've marked it up, so that'll be the shape. And just to check that my angle's correct, I'll just put this on here. So we're looking for 35, and that's pretty much spot on. So what I'll do first of all, I'll go over to the mill and I'll drill and ream the holes here. So now it's just a matter of milling this down to shape. Well, they seem to have worked out okay. I used a hand file just to put the radius on. Not perfect, but I think it looks alright. So what I need to do now is to get on and machine the fulcrum hub, and these will fit into the fulcrum hub. Okay, so the fulcrum hub is made out of a piece of brass, and it's not that big actually. It's only just over 1/4 of an inch in width, and it's got a diameter of 1.045 of an inch, and it's got a hole in the centre and 2 holes here on the outside, which will be used to bolt it to the flywheel, and it's got a couple of slots here for these to fit into. And the idea is that they'll be soldered in place like that. Now I've turned this piece of brass down on this end so it'll fit in this collet chuck. on the lathe. So what I'll do first of all, I'll face this off, and then I'll machine this side down to 1.045 of an inch. I'll machine it all down to that diameter, even though I only want this end bit. Once I've done that, I'll take the chuck off the lathe, and then I'll mark it up, and then presumably we'll go to the mill and start some milling. So to help with the marking up, I've used this magnetic V-block, and it's rock solid. Now the diameter, I managed to get it spot on 1.045 of an inch. So if I set the gauge on the top and set it to 0, then if I reduce it by half the diameter, which is 0.5225, that'll put me dead centre. And then once I've got the dead centre mark, I can then do the marking up based upon the drawing. But I'll do all that off camera. Well, that seems to have worked out okay. So I've put the wiggler on and got centre, and I've zeroed the DRO, and I've also made sure that my markup lines are parallel with the bed. And they are, so I think we're good to go. So I'm just going to use this 3mm slot drill just to cut the groove, and I'm going to plunge cut to a depth of 0.2 of an inch. So this could take a while, but I'll continue going right along the length of it. And once I've done that, I'll just do a final cut horizontally. But I'll do all that off camera. So the plan now is to silver solder these pieces together, and I'm using some MAP gas plus, or MAP plus gas, and I think that can get up to the flame about 3000 degrees C. So I've used it on silver solder before, but this is a massive heat sink here, so it might take a while for it to get heated up, and in the process I might actually have to move the camera away just to stop it from melting. pretty convinced the solder's run into that joint, so I need to get the other side, but I'll do that bit off camera. Well, that certainly seems to have got it. You can see where the silver solder has run into the join on both sides. Okay, so I thought I'd clean it up before parting off, and before parting off I need to open the centre up to a hole of the size of 0.602 of an inch. I've already centre drilled, so I'll open it up in stages. I think this is an 8mm. I'll probably go, I don't know, 12, and then to my biggest drill bit, and then I'll use a boring bar. And it's absolutely chucking it down outside. Don't know whether you can hear that. Okay, so I opened it up to 12mm in diameter, and I need to open it up to, let me see, 0.602 of an inch. Well, 12mm is 0.472 of an inch, so take that off 0.602, I get 130 thou, divided that by 2 is 65 thou, which is equivalent to 1.651mm, which is 82 increments on my dial. So let's see how we get on. So just 10 out time, pull it out. .603, happy with that. Well, I made these little pins off camera, and all in all it's looking pretty good so far, and it hasn't even fallen apart, which is a bonus. Well, I decided to make the little arms for the weights off camera. They're fairly straightforward in terms of machining, 3 components there, but the tricky bit is holding them together for silver soldering. But I did manage to do it, so I'm really happy with the result. Now I've cheated in terms of the weights. I've never tried turning spheres, and in fact I don't have a tool to do it, so I bought these on eBay. So what I need to do here is to drill through and tap them to 5B40 part way through, and then on the other side the hole will be used to hold some little sort of lugs for the spring to attach. So in order to drill these brass spheres, I've decided I'm going to use the collet chuck. So I've taken it off the lathe and put it on the mill, and I've put this coaxial indicator on just to make sure it's on centre. So I've centred it up. It's pretty close, so I'm happy with that. So my plan now is to put the ball bearing in the chuck, and then I can centre drill and tap. Well, I don't know, it took me an hour to make each of these little eyelets for the spring. But anyway, I got there in the end. And I've set up this little test bar just to make sure that it functions correctly. And it does seem to work okay. Now, I've read somewhere that sort of the best maximum speed for these hit and miss engines is around about 500 RPM. So I thought I'd just have a bit of a try, really, making a spring, putting this on the lathe and seeing if I can make a spring that sort of opens up at 500 RPM. I don't know whether I'll be successful at doing that, but I think it's worth a try. Well, this is my first attempt at making a spring for this governor, and we'll give it a try. The thing to watch is this coming inwards, and it's at that point, or around about there, that it'll open up the exhaust valve and keep it open, so it'll freewheel, and then once the revs go down again, the exhaust valve will close. So at 100 RPM, 260, 300, it's closing up a bit, is that gap? 350, 370, 420, 520, and it's there. As we decrease the speed, it should come back. Wow, I'm happy with that. Well, I just can't believe how lucky I was with making that spring. It seemed to be quite accurate in terms of what I need, and I turned it on this piece of bar. It's only 1/8 of an inch in diameter. It was size 1 music wire, and there were about 8 turns on it, and I mean, I'm guessing that sort of like the maximum speed of one of these hit and miss engines should be around about 500 RPM. But if anybody's sort of any better ideas on that, I'd appreciate any comments. And I mean, it seemed to work really well on the lathe, that test run. Anyway, I hope you like the results so far, and I hope to see you later.